Hello, so today we are going to be looking at dew point temperature. You are going to need your reference page open to page 12, your reference table to 12. So we're looking at dew point and relative humidity. So dew point, we're going to get into what that is, but first let's go back to what we were doing last time, kind of like rehash what we did. So no, as air temperature gets lower, only the air gets smaller. We just looked at that yesterday. Not the amount of water vapor in the air. So when water is holding as much water vapor as it can, it has reached maximum saturation. It has reached saturation. Like it can't handle anymore. So this is what I'm talking about. Remember, we saw this cup. This cup would be like the air, and it's holding only 100 milliliters of water. This is really, really hot air, so it can hold a lot. But then it starts getting cooler, and as that beaker, or as it gets cooler, that water stays the same, but you notice that it starts to get filled up more because the amount of water doesn't go away. It's just getting smaller because the air is getting colder. So looking at this, have you ever had a glass of water? Well, this is a good explanation of dew point temperature. Glass of water with ice in it. So there's other ways for air to reach saturation besides getting colder. The air, when it does become saturated, it's reached its dew point temperature. Dew point is the certain temperature to which air must be cooled to reach saturation. So it has to get so cold so that it gets filled with all this water and it's reached saturation. This glass, like the glass I was talking about, that demonstrates it. The air touching the glass surface has become cooled because of what's inside with the ice to the dew point temperature, causing the water vapor in the air to condense on your cup, which is sometimes why you need coasters. And this is called dew. So, meteorologists, they know that if they could tell what temperature the air needed to cool in order for rain to happen, it could help them in forecasting. So what do? They use this thing that you see right here, this instrument. And if you think back to Tuesday on the not vocab, but like the different instruments you could see, this is a sling psychrometer. A sling psychrometer has two thermometers. So I got one right here. It's got two thermometers. You got one on this side and one on that side. One that has a sock on it. I know you guys can't really see the sock. There is a sock in there. It's a little bit moistened. I got some water on it. And the handle that I have right here allows it so that I can swing it. So how do you use this weird looking contraption thing called a sling psychrometer? Well, first you put a couple drops on here. Like I said, I did put some water on here and located on the thermometer. So there's some water on here. I spilled it all on my floor trying to do this, but there is water on here. Then you're going to swing in circle, kind of like this, in a circle for about a minute. So what is going on with this that makes this work well? Well, the drier the air, the more evaporation will occur. That's on the wet bulb only. Since evaporation is a cooling process, remember that the curve that I showed you, evaporation is cool stuff down. It sucks energy out of whatever's there. It makes the temperature cooler. And the more humid the air, the less evaporation. And since that's occurring, this temperature will be warmer. One thing to note, though, the dry bulb, that's the one that doesn't have the sock on it, just records the air temperature, where the sock records the dew point. So the drier the air, the faster, the more evaporation will occur, more cooling. Therefore, the difference between would be greater. So I've got right now 12, 14, about 16 degrees on the wet bulb side, and on the dry bulb right there, we've got 23. The more humid the air, the less evaporation will occur, resulting in less cooling of the wet bulb thermometer. I think I've got a 6-degree difference right now. That's about even, like halfway. Therefore, the difference so if it's more humid, less cooling, the difference will be smaller. More evaporation, more cooling, greater the difference. So the difference between the wet and dry bulb goes up the drier the air is, and it decreases the moisture the air goes. And so you're going to have this thing. It's on page 12. It's at the top, dew point temperatures. So how do we use this? Well, first off, you're looking at the top. This is the difference between the wet and dry bulb. That means you're just going to subtract the two numbers of the wet and dry bulb, and that's where you're going to get these numbers. And yes, you could get a 0. That is possible. On the vertical side, this up and down side, this is the dry bulb temp. So the thing I want you to know, this is not the wet bulb temp. It is the difference between the two. Very important you know this. Kids do get that mixed up. This is the difference. So the resulting number, where the row and the column meet, kind of like battleship, gives you the dew point temperature in degrees Celsius. So it's anything right in this box right here. But if you notice right here, these are all even numbers. So a median dew point value must be calculated on an odd dry bulb number. So between 24 and 26, there's 25. That line's the 25 line. That's what you would have to look. So we're going to do a little bit of practice. So first things first. If I have a dry bulb temp of 22 and a wet bulb temp of 20, what I need to do is subtract the two. 22 minus 20 is 2. So I know I'm going to need right here. And I'm going to need right here. What I'm going to do is go down here until I hit 22 and I'm left with 19. That's my answer. How about 22 and 13? 22 and 13, I need a calculator because my brain doesn't work that fast. It's a 9. 22 and 13 is 9. So I'm going to have that 9 right there, and I'm going to pull it all the way down to the 22 mark, and I've got 5 degrees. 20 and 14, that's a difference of 6. So at 20, I'm going to go over to 6, and I get 10. One thing to note, when you're doing this, a lot of students, even adults, go like this. They'll do 20, and they're 1, 2, 3, 4, 5, 6, so it's got to be a 12. Well, the one thing you have to realize is you have to take into account 0 is also on there. And so always do 0, 1, 2, and if you want to go across like that. So the answer is 10. 15 and 12, so 15 with 3. So I'm going in between 14 and 16. I'm going over 0, 1, 2, 3. So in between 9 and 11 is 10. 9 and 3, difference of 6. So I go in between 8 and 10. Difference is 6. So I'm going to go over here. What is the difference between 5 and 9? 6. I believe it's supposed to be 7. I might be incorrect on this one, but I think 7 is supposed to be the answer, and for some reason I put 7.5. Pretty sure it's 7. 8 and 6, a difference of 2. 0, 1, 2, 3. 17 and 17, let's see. 17 is in between 16 and 18. Go over here, it is 17 degrees. My favorite ones. Okay, so 26 and 22, there's a 4 degree difference. 26 and 2, 0, 1, 2, 3, 4 is a 20. -4 and -2, here's where it gets tricky. You just have to figure out the difference between the two numbers. 4 and 2, there's a 2-digit difference. So -4 over 2, 1, 0, 1, 2, -12 is my answer. 13 and 6, difference of 7. So 13, 0, 1, 2, 3, 4, 5, 6, 7. The answer should be 0, and I have a feeling I put an outrageous number. Yeah, definitely did. So that should be 0. All right, so relative humidity. So that's the ratio comparison between the amount of water vapor in the air and how much water vapor the air can hold at that temperature. So you look at the relative humidity. If it's really, really high, chances are the saturation is going to be high. We'll see that in a second. So increasing air temperature decreases the relative humidity. That means more water can be held. Think back to what we first said. So as you increase, you can hold more, which means your relative humidity will be less. If the air temperature increases, the amount of water vapor in the air remains the same. The relative humidity will decrease. So if the amount of water vapor in the air increases and the temperature remains the same, the relative humidity will increase. So if the temperature is the same, but I increase the amount of water, you're going to get more humidity out of it. So this again, it's on page 12. It's on the bottom part. Again, you're going to find the difference up at the top, the dry bulb right here, and they're still evens, and the resulting numbers right there. Still the same as the dry bulb, only now it's relative humidity and it's in percentage. So let's look at this, 22 and 20. Remember there's a 2-degree difference, 0, 1, 2, 83%. This is in percent. The other one's degrees Celsius, 22 and 13. 22 and 13 going over 6, 53. I have 33. I don't know why there's 33. I did 9. That's because it's 9, a difference of 9, because I can't count today. 20 and 14, that's a difference of 6. 0, 1, 2, 3, 4, 5, 6, 51. 15 and 12, again, I'm in the middle. I'm going over 3. 68. I went over one too many, didn't I? No, I didn't. And I had issues. Should be 68. I apologize for that. It's a 68. 9 and 3 is 6. So 1, 2, 3, 4, 5, 6. In between 28 and 33. I still got that one wrong. I think I went over one too many. Yep. So that one's wrong. See, even I get things wrong. 8 and 6 is 2. 8. 0, 1, 2, 74. 17 and 17, one of my favorites, because that's going to give you 100%. Anything in the zeros, difference of 0 is 100% right off the bat. 26 and 22 is a difference of 4, which gives me a 70. Negative 4 and 2, so that's a difference of 2, gives me a 54. And 13 and 6 is 7. So between 28 and 33 gives you, yep, I did that one wrong too. So in between 33 and 38. All right, so make sure you work on the activity. If you have questions, please Zoom with me, email me, or class tag me. Hope you have a great day.